So it's time to apply what you've learned so far in this deep learning course. Your final project is to take some real-world data, we talked about this in the ethics lecture actually, of masses detected in mammograms, and just based on the measurements of those masses, see if you can predict whether they are benign or malignant. So we have a data set of mammogram masses that were detected in real people, and we've had real doctors look at those and determine whether or not they are benign or malignant in nature. So let's see if you can set up a neural network of your own that can successfully classify whether these masses are benign or malignant in nature. Let's dive in. So I've given you some data and a template to work from at least. The data that we're going to be working with is in your course materials. The mammographic_masses.data.txt file is the raw data that you'll be using to train your model with. And you can see it's just 6 columns of stuff. What do those things represent? Well, I'll show you in a minute. There's actually a description of this data set in the names.txt file here that goes along with that data set. But to get you started, I've given you a little bit of a template to work with if you open up the deeplearningproject.ipynb file. So this came from the UCI repository, and I gave you a little bit of a link to where the original data came from. That's actually a great resource for finding other data to play with. So if you're still learning machine learning, that's a great place to find stuff to mess around with and experiment with. But for this example, that's the one we're going to be messing with. So here's the description of those 6 columns. One is called the BI-RADS assessment, and that's basically a measurement of how confident our diagnosis was of this particular mass. Now that's sort of giving away the answer. It's not what we call a predictive attribute, so we're not going to actually use that for training our model. Next, we have the patient's age. We have a classification of the shape of the mass. We have a classification of the mass margin, how it looks like, the density of the mass. And finally, we have the thing that we're trying to predict. So this is the label, the severity, whether it's benign, 0, or malignant, 1. So we have what's here a binary classification problem, very similar to stuff that we've done earlier in the course, and you shouldn't need much more than to use code snippets from earlier exercises in this course and adapting them to this data set. Okay, now one little caveat here. Typically when you're doing machine learning, you don't want to deal with what we call nominal data, and both shape and margin are technically nominal data. While we're converting them to numbers, those numbers aren't necessarily meaningful in terms of their gradation. You know, going from 1 to 4 doesn't mean that we're increasingly going from 1 to round to irregular in a linear fashion. But sometimes you have to make do with what you have. It's better than nothing. And at least there is some logic to the progression of numerical scores here to these descriptions. So they do generally go from more regular to more irregular as those numbers increase. So we're going to go ahead and use those anyway. This is important stuff. You know, there's a lot of unnecessary anguish and surgery that comes along from false positives on mammograms. So if you can build a better way of diagnosing these things, all the better. But again, think back to my ethics lecture. You don't want to oversell this. You want to make sure this is just a tool that might be used for a real human doctor, unless you're very confident that the system can actually outperform a human. And by definition, it can't, because we're training this on data that was created by humans. So how could it possibly be better than a human? Think about that. All right, so your job is to build a multi-layer perceptron to classify these things. I was able to get over 80% accuracy with mine. Let's see how you can do. Now, a lot of the work is just going to be in cleaning the data, and I'll step you through the things you need to do here. So start by importing the data file using the read CSV function. You can then take a look at that, convert the missing data into not of numbers, and make sure you import all the column names. You might need to clean the data, so try to get an idea of the nature of the data by using describe on your resulting pandas data frame. Next, you'll need to drop rows that have missing data, and once you've taken care of that, you need to convert the data frames into NumPy arrays that you can then pass into scikit-learn or into Keras. Okay? So you also need to normalize the data before you analyze it with Keras. So a little hint there is to use preprocessing.standardscaler out of sklearn. That can make things very easy for you. That's the one thing that we haven't really done before. The rest of this you should be able to figure out just based on previous examples. Once you have the data in the proper format, it's then pretty straightforward to build an MLP model using Keras, and you can experiment with different topologies, different hyperparameters, and see how well you can do. So I'm going to set you loose here and give this a shot. Let's see how you do. When you come back in the next lecture, I'll show you my solution and how I walk through this myself. So go forth and practice what you've learned.